The length of conical pendulum L is equals to 2 meter and its bob has a mass 0.2 kg. The string will break if tension T exceeds 4 Newton. So if we don't want the string to break, our tension must be less than or equal to 4 Newton. The smallest angle the string can make with the horizontal is. This string is making some angle with the horizontal. We have to tell the minimum possible value of this angle. This is the question. Now, the question says conical pendulum. What is this conical pendulum? Well, if you pull a tail of a mouse and you rotate the mouse in a circle, this becomes a conical pendulum. Now, instead of mouse, we can have bob also. And usually our bob moves with constant speed, but the velocity changes at every instant. Can you see? The motion is circular motion. Now, before we tackle our problem, let me tell you a general case about conical pendulum and how you can solve all the problems related to conical pendulums. Whenever we have tension in some direction, we can always break it into two parts. This is our first step. So this is Ty, tension in the vertical direction, and we have another tension, another component of tension, which is Tx. This is along horizontal plane. Now, Ty is the one which balances out mg. We can see there is no acceleration in the vertical direction. Therefore, Ty is equals to mg. Now, we haven't completed the free body diagram of this bob yet. If we see the bob from a ground frame of reference, can we see what is the actual trajectory of this bob? You will say it is circular trajectory. It is moving in circular path. All right. Whenever anything moves in circular path, does it have any acceleration? Let's say the speed is constant. Is there any acceleration of this bob? You will say yes, there is. Anything moving in circular motion with constant speed has one acceleration for sure. That acceleration is directed towards the center, and that acceleration is AC, the centripetal acceleration. So this Tx is the one which is providing this acceleration. We can write Tx is equals to m times centripetal acceleration, and the centripetal acceleration is usually written in terms of speed. This is v square by r, where r is the radius of circle. Now, from these two equations, we get everything about conical pendulum. Now, you might wonder, how do we get Tx and Ty? Well, for this, we must know the tension T, and we must be familiar with some angle. Usually, the angle from the vertical is given. But in our question, we had angle from the horizontal. Can you see it? Right. Now, let us look at our case, our particular case. We have this angle from the horizontal. This is phi. Mg is acting in the downward direction, and tension, one component of tension, is in vertical direction. We will call it Ty. Value of Ty we can see is equal to T sine of phi. Can we say it? T sine phi is Ty. Yes. And there will be another component of tension, Tx, but we are not concerned with Tx at all. Now, Ty is T sine 30. This is balancing out mg. So, T times sine phi is a constant. Mg is a constant. Now, product of two things is a constant. Can we see? Yes. Now, we wanted the minimum possible value of phi. This was asked in the question. What is the smallest value of the angle from the horizontal? If phi is minimum, this means sine phi is also minimum. This means tension must be at its peak value. And what is the peak value of tension? Can you see the peak value of the tension? Yes, we can. The peak value of tension is 4 Newton. Otherwise, if the tension is greater than 4 Newton, the string will break. and there is no conical pendulum to calculate anything. So peak value of tension is 4. Now, if we place tension as 4 and we have sign of phi minimum, this is equal to mg. What is mass? Mass is 0.2, g is 10. So mg becomes 2. Now let's take 4 on the other side. So we have 2 by 4 as sine phi. This is equal to half. Now tell me the minimum possible value of phi. Minimum possible value of phi is coming out to be 30 degree. Alright. Now we get phi minimum to be 30 degree. Can phi be greater than 30 degree? Yes, we can have phi greater than 30 degree. This could be the possible angle, and even this angle, which is 90 degree from the horizontal, this is also possible. So any value of phi greater than 30 degree is possible. But in our question, we had to find the minimum value of phi, and we mark option B as the correct answer for our question. Let us see what this question is all about. This is really interesting. 3 masses of small size are attached by light inextensible strings of various length. Various length is important. Of various length to a point O on the ceiling. So these strings are connected to same point on the ceiling and they are of various length. L1 is different than L2 is different than L3. So all these lengths are different. Now let us see what the question says next. All the masses swing around in horizontal circle of various radii with the same angular speed omega. So omega is given to be same. Now omega is same. This is important. And the question further says we have to pick the correct statement. Let us see what the statements are saying. Statement A says the vertical depth of each mass below the point of suspension from the ceiling is different. So according to option A, these depths below the point of suspension are different. So we have different depths, H1, H2, H3. This is what option A says. Option B says that radius of horizontal circular path of each mass is same. It is saying that whatever be the length of the string, but the radius of their circular path R is actually same. So this is option B. And option C says that all the masses revolve in same horizontal plane. This means all the masses are having the same depth from the ceiling. So this H is same for all the masses. This is what option C says. And option D says all the particles must have same mass. Well, option D is bizarre, but anyway, let us look at this question. Now, how do we approach this question? Our approach should be simple. We have the condition that omega is same. Now, we can find out what is R as a function of omega or what is H as a function of omega. If for same omega we get same R, we will mark option B. If for same omega we get same H, we will mark option C. All the masses revolve in same horizontal plane, that is the depth is same. So for same omega, what is same? Is R same or is H same? This is the question. Now how do we approach the problem? Let's take a general case. So here is our favorite ball. And this ball is having mg in the downward direction, gravitational force. Is there any other force? Yes, there is tension in the string T. Now, let us call this angle from the vertical to be theta, the depth of this ball to be h. This is h. And let's call the radius of the circle to be r. And guess what? This angle will also be theta. Now, this ball is moving in a circle. And anything moving in a circle, does it have any acceleration? You say yes. If the speed is constant, then also we have some acceleration. and that acceleration is directed towards the center, and that acceleration is known as centripetal acceleration. We will call the acceleration to be A. Let me just draw A right over here. This is acceleration A. Okay. Now, let's see what are the forces. Tension and mg. We can break mg, we cannot break mg, but we can break tension into two parts. This would be easy for us. So tension T cos theta is like this, and T sin theta would look like this. This is T sine of theta. Well done. Now let's write the equations. The equations are beautiful. We can first of all say that T sine of theta, this is equal to ma. What is the acceleration of this ball? Acceleration, we can write that in terms of omega and r. The centripetal acceleration is omega square r. Well done. And T cos of theta, what does this component of tension do? This component of tension is responsible for balancing out mg. So this is equal to mg. Why not divide these two equations? T will get cancelled out and we will get something like this. Tan of theta is equals to omega square r by g. And what is the value of tan theta? Can you see this right angle triangle? Can you see this right angle triangle? Yes, we can see the right angle triangle. What is the value of tan theta? It is perpendicular upon base. The side opposite to theta is r. This is the perpendicular. So tan theta is basically r by h. Well, r by h must be equal to omega square r by g. R gets cancelled out. Let me beautifully cancel out r. Tichu. And what are we left with? We are left with the depth. Depth h is equal to g by omega square. For same value of omega, depth is same. I repeat, this is interesting. For same value of omega, depth is same. This means if we have lengths of the string to be different, L1, L2, L3 are different. But if omega is same, then the depth will be same. Well, this means all the balls revolve in the same horizontal plane. And we can mark option C, all the masses revolve in same horizontal plane, as the right answer for our question. A ball is thrown vertically up from the ground. The correct momentum height diagram is. So we have four graphs between momentum and displacement, or the momentum and height. And we have to choose the correct graph. The particle was thrown initially in the positive direction. This is the positive direction. And the velocity obviously points in the positive direction. Now, can you tell me something about momentum of the particle? What is the formula for momentum? You remember the formula from the momentum is mass times velocity vector. And can you see the momentum initially? Is it positive or negative? Is the momentum positive or negative? You will say positive. All right. Now what will happen next? When the particle reaches the highest point, what is the momentum of the particle? We see that at the highest point, the particle has zero velocity. This means momentum is also zero. Right. And what will happen after that? What will happen after the particle start approaching the ground? You will say, well, now we have negative velocity. Therefore, the momentum is also negative. So momentum was initially positive, then it became zero, and then it became negative. Let's check the graph. Which graphs shows it? We can see only graph C and graph D shows it. The momentum is initially positive, then it becomes zero, and then it becomes negative. Right. Now, which of these graphs is the correct one? We have eliminated A and B. Half of the job is done. Now, to get the other half right, we can get the exact equation between momentum and displacement. How to get that equation? Well, we can get the equation between velocity and displacement, and then we can try it for momentum and displacement. So, tell me the equation between velocity and displacement. Remember it. Equation between velocity and displacement. Yes, it is the third equation of motion. We have v square is equals to u square minus 2gh. Yes. Let's multiply both sides by m square. So we have m square v square is equals to m square u square minus 2m square gh. And now mv is the momentum. So we have the equation momentum square is equals to initial momentum square minus 2m square gh. This is the equation between momentum and displacement. And can you see that this equation is something like this? Y square is proportional to minus x plus some constant, obviously. So this equation is not a straight line equation. So option C is also eliminated, and we are left only with option D. So that would be the correct answer for our question. Let's have a look at a question based on relative motion. This is a Rain Man problem. A man holds an umbrella at 30 degrees with the vertical to keep himself dry. Nobody wants to get wet, so he wants to keep himself dry, and he's holding the umbrella at 30 degrees with the vertical. Fine? Okay. Then he runs at the speed of 10 meters per second and finds that the raindrops are hitting vertically. So, this was the initial situation when the man was standing. The raindrops were coming at an angle 30 degrees. And then when he runs, he finds that with respect to him, the raindrops are coming vertically down. So this is velocity of rain with respect to man. And initially we had only velocity of rain when the man was standing. So this is velocity of rain with respect to ground or earth. Now let's go back to the question. The question is asking us to find the speed of the raindrop with respect to running man and with respect to earth. So the question is asking us to find out this speed and this speed. Now, how will we do the job? First of all, we remember the formula that the velocity of rain with respect to ground is velocity of rain with respect to man plus velocity of man himself with respect to ground. This is a simple formula. Now, we need to visualize this formula. So let us add the two vectors. Let's add velocity of rain with respect to man to velocity of man himself. So this is velocity of rain. We can see it over here. And velocity of man is like this. This has the magnitude 10. Now the sum of these two vectors will give us the final third vector. This is velocity of rain with respect to ground or earth. Here we have VR. Okay. Now, can you see that this angle is 30 degrees? Yes, we can see it. Now, tell me, what is sine 30? Tell me from this right angle triangle, what is sine 30? Sine 30 is perpendicular upon hypotenuse. Alright, what is perpendicular? It is 10. So we have 10 divided by hypotenuse. What is the length of hypotenuse? The magnitude is VR. So, sine 30 can be written as half. Have we found out the value of VR? Yes, we have found out. VR is equal to 20 meters per second. Very good. So, this is 20. Alright, we got one part correct. Now let's move on to the next part. This was 20. Now can we find out what is the length of this side also? Yes, we can find out. Okay, how to find out? Well, we know that cos of 30 degree is equal to root 3 by 2. And from this right angle triangle, cos 30 is speed of rain with respect to man divided by the length of the hypotenuse. The length of hypotenuse, we have just calculated it. It is 20, right? So let's divide it by 20. And we are getting that speed of rain with respect to man is 10 root 3. Well done, well done. So we have both part right. So let's go to the option. Let's see. Speed of raindrops with respect to running man. It came out to be 10 root 3. So where is 10 root 3? Option C. And speed of raindrops with respect to earth. It came out to be 20 and we have 20 over here. So option C is definitely the correct answer for our question. Let's see this interesting question on projectile motion. Two particles A and B are projected simultaneously with velocities 11 meter per second and 15 meter per second. Find the time when they collide. Oh, these two objects are colliding, and this green object follows this path and the red object follows this path, and they collide at this point after time t, and we have to find out what is the value of this time t. Now, these two objects were projected simultaneously. So let's see what is the horizontal component of displacement of the red object. This red object covers this horizontal component of displacement in time t. And the green object, this object covers the horizontal component of displacement like this. Now, when we add these two horizontal components of displacement together, what do we get? We get something as 40 meter. Can you see it? Yes. So this is the concept we will use to solve this question. We will learn how to find the horizontal component of the displacement, and then we will add the displacement to get 40, and from that we will calculate time t. Now, what is the horizontal component of displacement? The concept of the projectile motion should be clear to us. We can break the initial velocities into two parts, ux and uy. Now, uy changes with time because there is gravity in the downward direction. But does ux change with time? Does the horizontal component of initial velocity change with time? You will say no. Why not? Because there is no acceleration whatsoever in the horizontal direction. Can we see it? Yes. Now, let's say the particle is somewhere over here. X comma y is the coordinate. Now, we can see that there is some horizontal component of displacement which is x. What is the value of this x? X is equals to ux times time t. Very good. So the particle at time t has the coordinate x and y, and x component is ux times t. And we can also calculate what is y. If you want to calculate y is equals to uyt minus half gt square. This is y. So that's how we calculate the coordinates, but only the x component of the displacement is needed to solve our question. So let's go back to our question. Here was the question, and the red object covered some displacement like this. We can calculate this displacement. It is very simple. What was the initial component of velocity of the red object? The initial component of the velocity of the red object in the horizontal direction. What is that value? You will say it is VA alone. There is no component of velocity in the vertical direction. Entirely everything is along the horizontal direction. Right. So VA will remain constant. VA, the component of velocity along the horizontal direction, will remain constant. But there might be some component of velocity along the vertical direction as the time goes on. But we are interested in the horizontal component VA, and if we multiply it by time t, we get this horizontal component of displacement of the red object. Now let's talk about the green object. We can break the velocity of green object into two parts, one along the horizontal and one along the vertical. The horizontal component of the velocity is VB sine of 37 degree. Yes, yes. Now, this horizontal component of displacement is VB sine of 37 degree times time t. All right, let's add them. Now, VA times time t. What is VA? VA has the value 11 meter per second. So, we have 11 times time t. And VB sine 37 times time t. What is VB? VB is 15. So, we have 15. What is sine 37? It is 3 by 5 and time t. Let's add them and we should get 40. So, from this equation, we get the time t. And we see that 5 3s are 15 and we have 11t plus 9t as 20t. It is equal to 40 and time t is 40 by 20, which is 2 seconds. And let us mark option B as the right answer for this question.